Let's practice solving quadratic equations by completing the square and taking square roots together. For number 1, we have this equation x squared plus 4x is equal to 10, and when we're completing the square, we do like having the x terms together on one side, and we're going to go ahead and put the constant on the other side. So this one's already arranged pretty well for us. Okay. Now, next we want to identify what our b value is. So remember, in standard form, the b value would just be the coefficient for x. So in this case, it's going to be 4. It's this value right here. And when we complete the square, what do? We always take the b value and we take half of it, and then we square it, right? That's the value that would complete the square. So in this particular case, we would have the value of 4. We would take half of that and then square it, okay? So half of 4 is going to be 2, and then 2 squared, that's going to equal 4. So that's the value that's going to complete the square here. All right, so we're going to go ahead and add 4 to the left side of this equation because that completes the square. And then if we do that on the left side, let's just make sure we do it on the right side as well so we keep the equation balanced. Now at this point, we have technically completed the square by adding 4 on the left side, so this should look like a perfect square trinomial to you, hopefully. That means that we can factor into 2 identical binomials of x plus 2 and x plus 2, right? That would be the left side of the equation. On the right side, you can just add this 10 plus 4, and that's going to equal 14. Now, in hopes of helping you visually understand what completing the square looks like, we've just found out that the dimension of the square would be x plus 2 on one side and then x plus 2 on the other side. So if we just multiply this x by x dimension over here, the area of this square would be x squared. Then if we multiply this dimension of x by 2, we would get the area of this rectangle would be 2x. If we go ahead and multiply this dimension of x by 2, this would also be 2x. And then what would complete the square here? Well, what would complete the square is if you multiply this 2 by 2, and that's going to be 4. All right, so this value of 4 that you can see in this box over here is really what completes the square. So hopefully you can see why we added 4 to both sides of the equation, because this 4 is what completes the square. That was sort of what was missing because we already had the x squared here. This x squared was over here, and then we already technically had this 2x plus 2x, which made the 4x. So really this 4 was missing to complete the square. On the left side of the equation, we can now go ahead and condense this to saying this is the quantity of x plus 2 squared, and that's equal to 14. Then we can go ahead and take the square root of both sides of the equation, just like this. And the square root of the quantity of x plus 2 squared is just going to be x plus 2. And on the right side, we're going to have plus or minus the square root of 14. Okay, now you should check to see if you could simplify this radical, but 14 only has the factors of 7 and 2, and neither of them are perfect squares. 1 and 14 are also not perfect squares. So let's go ahead and subtract 2 from both sides of the equation just to isolate the x. And so if we subtract 2, we're going to get x is equal to negative 2 plus or minus the square root of 14. These would be the 2 solutions for this quadratic equation. And if you wanted to write them separately, feel free to write x is equal to negative 2 plus the square root of 14, and then x is equal to negative 2 minus the square root of 14. And if it helps you kind of conceptualize these values a little bit better, this first one would be about 1.74 if you were just looking for like a value that's approximate because it's an irrational number, and this would be equal to roughly negative 5.74. Right, so these would be the actual numbers if it's a little bit easier to understand. All right, so for number 2, we have the equation x squared plus 6x minus 3 is equal to 0. So I'm just going to start by just writing the equation again one more time here. So we have x squared plus 6x minus 3 is equal to 0. And what we want to do is get the constant alone to the other side. So I'm just going to start by adding 3 to both sides of this equation. So it looks a little bit more like the equation we had in number 1, right? So we're going to have the x terms isolated to the left side, so x squared plus 6x. And then I'm going to leave some space so we can complete the square. And then we have 3 over there on the right side, that constant, okay? So for this particular problem, we see that b is equal to 6. So we want to use that formula where we say that half of b and we square it, that's going to equal to the value that will complete the square. So in this case, what do we have here? Well, b is 6. So we're going to take 6 and take half of it, and then we're going to go ahead and square it. Now, half of 6 is going to be 3, and if you square 3, that's going to equal 9. So that's going to be the value that completes the square. So we can go ahead and add 9 to the left side of the equation and then add 9 to the right side of the equation. So again, visually, we can take a look at this. We have this perfect square trinomial of x squared plus 6x plus 9. So if we take a look at this, this should turn into the quantity of x plus 3 on one side and also x plus 3 on the other side, right? So the area of this square over here would be x times x, or rather x squared, right? And then the area of each of these rectangles would be the dimension of x by 3. This one's also x by 3. So you can see that the area of each of these is going to be 3x and 3x. And then what value would complete the square here? Well, when we took half of 6, that was 3, so 3 times 3 equals 9. So that's why we added this 9 to both sides of the equation, because that's the value that would complete the square here. Okay, so we go ahead and see if we can break this up into our two binomials. So this is going to be the quantity of x plus 3 times the quantity of x plus 3. And you could always FOIL this back out to see if it works. And on the right side, we have 3 plus 9, and that's equal to 12. So we can go ahead and write that. Then let's go ahead and condense this. So this is the quantity of x plus 3 squared, because there's two of them, that equals to 12. And then let's go ahead and take the square root of both sides of the equation, since we have the square isolated. So the square root on the left side is just going to leave us with x plus 3. And on the right side, we're going to have plus or minus the square root of 12. So the square root of 12 is a radical that can be simplified. So let's go ahead and just look at that on the left here. So if we have 12, we can separate the square root of 12 into the square root of 4 times the square root of 3, right? And the square root of 4 would be 2, and the square root of 3, that's irrational. So we're just going to keep that as root 3. So that's as far as we can go. So we have the x plus 3 on the left side, and then that's equal to plus or minus 2 times the square root of 3, or 2 root 3. Okay, next we can go ahead and just subtract 3 from both sides, so we can get x completely by itself. So if we do that and do subtract 3, then we're going to get x is equal to negative 3 plus or minus 2 root 3, or 2 times the square root of 3. These would be our two solutions for this equation. If we want to go ahead and separate these, we can write that x would equal negative 3 plus 2 root 3. Or we could say that x is equal to negative 3 minus 2 root 3. This first one would be approximately equal to 0.46 if you round to the nearest hundredths place, and the second one would be roughly equal to negative 6.46. All right, let's check out number 3. For number 3, we have the equation 4x squared minus 40x minus 12 is equal to 0. Now, if you look back at problems 1 and 2, notice how they had a values of 1, so this was a little bit different. Here we have an a value of 4. Now, if we can factor out a GCF, we really want to try to do so. So in this case, notice how 4 is a common factor, or 4 is the GCF for all three of these terms. So if we factor out a 4, we're going to get x squared minus 10x, because 40 divided by 4 is 10, and then 12 divided by 4 is going to be 3, so we're going to have this x squared minus 10x minus 3 is equal to 0. Okay, now that gives us a leading coefficient for x to be 1, and we can actually, since we're dealing with an equation, divide both sides of the equation by 4. And this is kind of nice because on the left side the 4's will cross cancel, and on the right side 0 divided by 4 is still 0. So this gives us an equation that's a little bit easier to work with. So we have x squared minus 10x minus 3 is equal to 0. At this point, we want to go ahead and isolate all the x terms to one side and the constant to the other side. So we can go ahead and add 3 to both sides of the equation. So we're going to get this equation of x squared minus 10x. I'm going to leave a space here so we can complete the square, and that's going to be equal to 3. Alright, so now we can see that b is equal to negative 10. So let's go ahead and write that down. B is equal to negative 10. And so what's that formula again for completing the square? Well, it's b divided by 2, or half of b. And then we're going to square that. So we really have this negative 10. We're going to take half of negative 10 and then square it. Half of negative 10 is going to be negative 5. So if you square negative 5, that's going to equal positive 25. 25 is the value that will complete the square. So let's go ahead and add 25 to the left side and then add 25 to the right side. Okay, so if we're looking at this visually, we had this x squared already. We had a negative 5x area and a negative 5x area. So where could this have come from? So this is really going to be x minus 5. and then x minus 5. All right, so I'm going to just go ahead and write it like this, x minus 5 and x minus 5, and that's a little weird vertically. And so what value completed the square? Well, if we had a -5 and a -5, that multiplies to get positive 25, so that is the value that completes the square here, okay? On the left side of the equation, we have this perfect square trinomial, which is going to factor into two of these identical binomials of x minus 5. So I'm just going to go ahead and write quantity of x minus 5 times a quantity of x minus 5. And on the right side, we have this 3 plus 25, which is equal to 28. Let's go ahead and just condense this a bit. So we have x minus 5, the quantity of that squared is equal to 28. All right, so now we have the squared isolated, so let's go ahead and just take the square root of both sides of the equation. If we do that, we're going to have x minus 5 is equal to plus or minus the square root of 28. Now off to the side, this square root of 28 is a radical that can be simplified. So if we take a look here, the square root of 28 we can separate into the square root of 4 times the square root of 7. The 4 I think is the only perfect square I can think of besides 1. So the square root of 4 is 2, the square root of 7 is irrational, so we're going to leave this as 2 root 7. So for here I'm going to write x minus 5 is equal to plus or minus the 2 times the square root of 7. And then we can completely get x alone by adding 5 to both sides of the equation. And so if we go ahead and do that, then x will be alone. So adding 5 to both sides here, we can see that x is going to be equal to 5 plus or minus 2 times the square root of 7. If you want to see these separately, we can say x is equal to 5 plus 2 times the square root of 7, or we can say that x is equal to 5 minus 2 times the square root of 7. This first one is approximately equal to 10.29 rounded to the nearest hundredths place, and the second one is about negative 0.29 rounded to the hundredths place as well. For number 4, we have one more here where we have 7x squared plus 28x plus 56 is equal to 0. So just like in number 3, it looks like we have a leading coefficient, or the a value is 7. So I think we can maybe factor out, looks like 7, 28, and 56 all have a factor of 7 as their GCF. So we can factor out this 7 here, right? If we do that, we're going to be left with x squared plus 4x plus 8, and that's going to equal 0. Okay, now that we factor this out, we have an equation, so we can go ahead and divide both sides by 7 so that we don't have to deal with that leading coefficient. It's not going to change our answer in any way. So we're going to have here x squared plus 4x plus 8, and that's going to equal 0 because the right side we have 0 divided by 7, that's still 0. Okay, now just like in all the other examples we did here, let's try to isolate the constant and the x terms. So on the left side, let's keep the x squared and 4x together. We're going to use those to complete the square in a moment, leave some space, and then 0 minus 8 is going to be negative 8 on the right side of the equation. All right, so how do we complete the square? We take this b value of 4. I'm going to go ahead and write that on the side here. B is equal to 4. And so that formula for completing the square is taking half of b and then squaring it. So b is 4 here, so let's take 4 and take half of it. And if we can go ahead and square that, half of 4 is going to be 2. 2 squared is going to equal 4. So 4 is going to be the number that will complete the square for us here. So we had this area of x squared, so we can go ahead and put that in this big square over here. We had this area of 4x, so that must be split here. So we have 2x and 2x, right? So based on that, this really must be x plus 2 on this side of the square, and then we have x plus 2 on this side of the square. All right, so what completes the square here? Well, this dimension is 2 by 2, so the area here that would complete the square would be 4, which is why we go ahead and add 4 to both sides of the equation. All right, so we have this perfect square trinomial. It factors into this x plus 2 and x plus 2. So we go ahead and break this up and say, okay, this is the factored form, x plus 2 times a quantity of x plus 2. And on the right side of the equation, this negative 8 plus 4, that's going to equal negative 4. On the left side, let's condense this so we can say the quantity of x plus 2 squared, that's equal to negative 4. And then we can go ahead and take the square root of both sides of the equation. We go ahead and take the square root. So on the left side, we took the square root, so we're just going to have x plus 2. And on the right side, we're going to have plus or minus the square root of negative 4. All right, so looking at this square root of -4 a little bit more closely, let's see if we can simplify this radical a bit. So keep in mind that the square root of -4, we can separate into the square root of -1 times the square root of 4. Now the square root of -1 is just I, right? And then the square root of 4 is going to be 2. So I times 2 is equal to 2I. So let's go back to our equation and say x plus 2 on the left side is equal to plus or minus 2I on the right side. Okay, now finally let's get x alone. We can go ahead and subtract 2 from both sides of the equation. If we go ahead and do that, then we're going to finally get x is equal to -2 plus or minus 2I. Those would be the solutions for this quadratic equation. Well, we can't get a decimal for this one because we have a complex number. We can separate this if you want to see. X would be -2 plus 2I, and x would equal -2 minus 2I. These would be the two solutions separated. So there you have 4 different practice problems of solving quadratic equations by completing the square and then taking square roots. I hope you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.